could literally print a new heart or design a prosthetic that feels just like a real limb. This isn't some far-off sci-fi movie. This is the world of biomedical engineering. Today, we're going to dive into how we're not just treating diseases anymore, we're actually building the future of the human body itself.
Just think about it for a second. That phone in your hand or the computer you're watching this on, that's all engineering, right? So what if we could take that same creative spark, that same problem solving, and apply it to the most incredible machine ever created, the human body? That's exactly the challenge biomedical engineers are taking on every single day. And they're doing it in some incredible ways. We're talking about everything from the artificial hip that gets a grandparent back on their feet, pain-free, to these amazing, complex algorithms that can actually predict a medical event before it even happens. They are, without a doubt, the invisible architects of modern health.
Okay, so what does a biomedical engineer actually do? Well, the career pretty much splits into two really cool paths. You've got the maker, and then you've got the analyst.
All right, let's break this down. On one side, you have the maker. This is your hands-on inventor, the person literally building and prototyping the next generation of life-saving devices. Think artificial organs, custom implants, that kind of stuff. And on the other side, you've got the analyst. This is your data detective, digging into the numbers, analyzing human movement, and trying to decode the body's secrets to find new ways to treat people.
And these pictures, they show it perfectly. You could be in a high-tech corporate lab, kind of like RN Biomedical, designing and building something like a new vascular implant. Or you could be in a hospital setting, say in a gait analysis lab, helping kids with walking disabilities. Totally different worlds, right? But both have an absolutely massive impact. So what does it take to be one or the other? Well, the skill sets are pretty different. For makers, you need amazing manual dexterity. We're talking about working with super tiny components, and you gotta be a wizard with CAD and 3D modeling. Now, for analysts, it's a whole different game. You need to be sharp with programming, think MATLAB or Python, and you absolutely have to have great people skills because you're working directly with patients and other healthcare pros.
Okay, but let's get real for a minute. What's the day-to-day actually like? We dug into what engineers in the field are saying, and honestly, it's not always what you might think.
So here's the first big reality check. This field is a marathon, not a sprint. I mean, think about it. When you're making something that's literally going to be put inside a person's body, you can't cut corners. There are no shortcuts. Every single step, every material choice, every bit of testing has to be absolutely meticulous. That's why these projects can take years, not just a few months. And get this chart might really surprise you. If you're picturing an engineer spending all day, every day in a lab coat, you might want to adjust that picture. According to one engineer, a whopping 75% of their time, 3/4 of it, is spent in meetings and on documentation. So why all the paperwork? Well, it's all about safety. The whole industry is heavily regulated by groups like the FDA. You have to prove, beyond a shadow of a doubt, that what you've built is safe. Every single step needs a paper trail. So good writing skills and being super organized, those are just as important as the engineering itself. Okay, so with all that rigor as a foundation, let's talk about the really cool, cutting-edge tools that are changing the game. This is where the digital world smashes right into the physical body. One of the biggest game changers is musculoskeletal simulation, and just look at this graph. The use of these simulations has gone absolutely nuclear in the last few decades. We're talking about going from just a few research papers here and there to literally thousands every single year.
So what are these simulations for? Well, they let us build what's called a digital twin of an actual patient. It's amazing. Engineers can scan a person's anatomy, create a model of their specific skeleton and muscles, and then simulate how they move. This means you can predict how a surgery or a new device might work for that specific person, all before anyone ever picks up a scalpel. And the progress here is just mind-blowing. Back in 2001, to simulate just one walking cycle, it took 10,000 hours of computer time. That is a lot. Fast forward to today, we can generate some of these dynamic simulations from a video you shoot on your smartphone. The leap in technology is just incredible. But the key here is it's not about always using the most complicated model possible. It's about using the right tool for the right job. You wouldn't use a sledgehammer to hang a picture frame. Sometimes a simple 2D model is all you need to answer a basic question.
But other times, if you want to know something super specific, like how much energy a runner is using, then yeah, you're going to need that complex 3D model with over 80 muscles.
All right, so you're probably wondering, how do you actually get into this field and where is all this cool tech heading?
Let's tackle a big question a lot of people have. Do you need a master's degree or even a PhD to really make a mark in this industry?
Okay, so we looked at what engineers in the field say, and the verdict is pretty clear. Your bachelor's degree, that's your ticket in the door. But after that, real-world, hands-on experience is king. In fact, a lot of companies value that experience even more than a master's. The advanced degrees really come into play if you want to go into a super specialized, deep dive research role.
And this is where the future gets really wild. The next big step is merging these physics-based digital twins with machine learning. Imagine a version of your digital twin that's constantly learning, constantly updating itself in real time with data from wearable sensors, like your watch or even your clothes. So what does that actually mean? It means we could predict injuries before they even happen. Think about it. Your digital twin could sense you're about to lose your balance and signal an exoskeleton to give you a little support, stopping a fall before it starts. That's not science fiction anymore. That's the roadmap. So look, biomedical engineering is a field of massive challenges. For sure, it takes patience and a ton of brain power. But the potential for impact? It's even bigger. Whether you're a hands-on maker or a data-driven analyst, you have the chance to literally change lives. So with AI and digital twins on the rise, the only question left is, what are you going to build?